Hey, how's it going, guys? In this video, we'll learn how to build an AI assistant desktop application using OpenAI API in Python. If you are new to OpenAI or OpenAI API, OpenAI is an AI research company founded in 2015, focused on developing user-friendly AI engines. Some of the popular products like ChatGPT or DALL-E are created by OpenAI. I have a tutorial on how to get started with OpenAI API in more detail, which you can find the link in the description below. Now, in terms of building the AI assistant desktop application, I'll be using GPT 3.0 DaVinci model, which is the latest capable AI model available from the API. Just an FYI, ChatGPT is based on GPT 3.5, which will be released hopefully soon. And for the GUI framework, I'll be using PyQt6, which is a popular GUI framework used by many companies and professionals. Now, before diving into the tutorial, let's review the prerequisites and the agenda first. Now, in terms of the prerequisites, you'll need to have basic foundations of Python programming, such as knowing how to work with arrays, dictionaries, loops, if statements, etc. Some knowledge working with classes will be extremely helpful. You also need to know how to install Python packages, and that's all the requirements. Now, let's cover the agenda. So I divide the tutorial into 4 parts. In part 1, we'll generate an OpenAI API key from OpenAI's website to grant access to OpenAI API service. If you don't have an account, go to openai.com/API to sign up for an account, and it's free. As a new user, you get $18 worth of credit to use. Just to keep in mind that the credit will expire after 3 months. In part 2, we'll create a Python virtual environment dedicated to the project. A Python virtual environment is an isolated environment for Python installations, which allows you to install packages and dependencies for a specific project while affecting other projects. This can be particularly useful when you have multiple projects with different requirements, or if you need to test your code against different versions of Python packages. In part 3, we'll be building the application. We'll first install OpenAI Python package in other dependencies. Then we'll create the OpenAI AI Assistance application in Python. And part 4 is going to be packaging the application so it can be distributed using a command line tool called pyinstaller. With that being said, let's dive into the tutorial. Now, to generate an API key, open your browser and navigate to openai.com/API. Then log into your account. Click on your username. Then click on View API Keys. Alright, so here I'm going to click on Create New Secret Key to generate a new set of API key. I'm going to leave this window open because I need to copy the key to my client secret manager file, which I haven't created yet. And here, for security reason, you won't be able to view the API key again to your OpenAI account. Now let's create a Python virtual environment dedicated to this project. Now find the directory where you want to host your Python project and launch your terminal. And I'm using Bash. Right, so let me make the window a bit bigger. Now to create a Python virtual environment, we want to run the command python-m vmv followed by the project name. For the project name, I'm going to name the project OpenAI _AI _assistant _app. Enter. Now going back to my directory, and let me open the project folder. Now we need to activate the environment, and to do that, so here in the scripts folder, we need to run this activate file. And since I'm using Bash, I need to insert the source statement followed by the file path, and it's going to be scripts/activate. And here I forgot to change the directory to my project folder. Alright, so let me do that first. And it's going to be OpenAI Assistant App. And let me see. Here we go. I sent her the typo before. Now if I run the command source scripts/activate, and that'll activate the OpenAI Assistance app environment. If you're using PowerShell, then you can run the file directly. Now let's install the Python packages to build the app. So there are 3 Python packages I'm going to install to build the application: OpenAI, PyQt6, and pyinstaller. And to install all the packages all together, I'm going to run the command pip install OpenAI, PyQt6, and pyinstaller. Enter. And once I install the Python packages, I'm going to create 3 files. So here in my terminal, I'm going to type touch. The first file is going to be the password manager or the client secret manager. And I'll name the file password manager.ini. The second file is going to be the application file. And I'll name the file app.py. And the last file is going to be a module that we're going to create to connect to OpenAI API service. And I'll name the file OpenAI playground.py. Enter. Alright, so going back to my project folder. So here are the 3 files that I just created. Now let me open the password manager file. So this file is going to be used to manage my API keys or my client secret. Inside the file, I'm going to create a section called OpenAI. Then I'll create a variable called API key. Now here I'll go back to OpenAI's website and I'll grab the API key. And I'll assign the key to the API key variable. Save the file and close. Now I can close the browser. Now before diving into the development, I want to give you a quick demo of the application that we'll be building in this tutorial. So here's the application. From the interface, we'll be able to adjust the maximum token that the API will be able to consume, as well as the temperature value and the presence penalty. So these are the 3 parameters that we're providing in this application that we'll be able to adjust. Then we have the prompt text and the output text. And since GPT is a language model, we can ask any question basically. So I can ask, what can you do with GPT API? And I can click on submit. And it's going to make an API request to the API engine. Then it's going to return the response. And here we have the status bar to tell us how much token that we have consumed using this API call. We can also create multiple tabs in case if we want to have multiple conversations. In case if we want to save the conversation or the output, we'll be creating this file menu to have this save output option to save the conversation as a text file. All right, so I'm going to put this on the side and let me launch my code editor. I'll be using VS Code to create this application. All right, so I'm going to open the OpenAI playground.py file first to create the OpenAI module. Now here, let me activate the environment first. So the environment is going to be OpenAI Assistant app. Inside the file, I'm going to import the OpenAI module and increase the font size. Then I'm going to create a class called OpenAI Playground. All right, so if we look at the constructor, so basically we're providing an API key when we create the OpenAI Playground object. Then we're creating an object called self.openai to reference to the OpenAI module. Then we need to attach the API key. And let me delete this line here since we don't need it. And to make the API call, I'm going to create a method called send prompt request. And this function takes one required parameter called prompt, which is going to be the input, followed by 3 option parameters: temperature, max tokens, and presence penalty. And for the output size, I'm going to hardcode the output size to 1, since for each conversation, we can only have 1 output at a time. Now let's look at the code block that creates the send prompt request method. And here, let me change the n value to 1. So when we make an API call to the OpenAI service, we'll be referencing the OpenAI module, .completion.create. Inside the create method, we need to provide the model ID. In this case, we're going to be using the DaVinci 3.0 model. Then we're providing the prompt text, temperature value, max tokens, and presence penalty. And for the output, we're going to store the output in this result dictionary. Inside the dictionary, we have things like ID, when the API code was made, the model ID, completion token use, prompt tokens, total tokens, and here's the outputs. Right, so for the output, I'm going to change these to reference the first element because the output is going to only be one item at a time. Dot text. And same thing for the status. And this will be finish, reason. Then from the function, we'll return the result object or the result dictionary as the output. And just in case, if we run into any exception, then we're going to use the exception block to capture any error. And it's going to be everything we need to write to create the OpenAI Playground module. Now save the file and open the app.py file. The app.py file is going to build the application interface. Some of the features we'll be implementing, such as being able to save the output to a text file, being able to control different parameters and menu bars, and create multiple conversations, etc. And since there are many moving pieces, I'll try my best to explain in the most logical order as possible. And for the application logo, I'll be using OpenAI's logo just for demonstration purpose. All right, so going back to the app.py file, I'm going to import the libraries first. So there are actually quite a few libraries that I'll be using to build this application. Let me hide the panel. So for this app, I'm going to import the system module. And to create the timestamp from datetime, I'm going to import the datetime class. And to load the API key from the config parser module, I'm going to import the config parser class. And these are the widgets I'll be using to create the interface, followed by some other pyqt6 classes that I'll be using, which I'll go to each one by one later on once I start doing the development. And finally, from the OpenAI Playground module, I'm going to import the OpenAI Playground class. Now, to construct the application main window, I'll create a class called app window, and I'll pass the Q widget as the parent class. And let me set the font size a little bit smaller. So this app window is going to be the main application interface, and Q widget is basically just a window itself. So here let me insert my main routine. So here I'm saying that if this is going to be the Python file that I'm going to execute to run the application, then I'm going to run this code block here. So this code block here is going to load the OpenAI API key. Then I need to construct the Q application instance, and I'll name the output as app. So basically, this line here is going to keep the application running in the background. And to create the application window, so here we need to create an object of the app window class. And I'll name the object app window. And to display the application, so here we need to use the -show method. And when we close the window, we need to make sure that we terminate the process using the system.exit method. And we'll provide the application.execution instance. All right, so if I go ahead and launch the application by pressing F5, we'll now have a blank window that we can freely insert any widgets to create the interface. All right, so let me close the window. All right, so let's go back to the app window class. Now I'll set the Windows property. So these two lines here is going to set the minimum window size. And for the window size, I'm going to set the width to 700. And for the height, I'm going to set that to 500. Then I'm going to set the Windows icon. And the set window title method is going to create the Windows title on the top. So in PyQt6, we can actually apply CSS style sheets to make the interface a little bit more elegant. And to keep things simple, I'm going to change the font size to 15, and that's it. Now, to keep the widgets organized, I'm going to create a dictionary called self.layout. Right, so here I'm getting an error. I think there are a couple empty spaces somewhere. Right, so let me fix that. Right, so basically what I did was I simply replaced the 4 spaces with a tab. And that seems to solve the inconsistent indentation issue. So for the main layout, I'm going to use Q box layout, stands for vertical box layout. So basically using this layout manager, I can organize or align the widgets vertically. And here I'm storing the layout manager inside this self.layout dictionary. And I'll name the key as main. Then I can set the application layout using the setLayout method, providing the layout object that I want to use. All right, so let me take a look what I'm missing. All right, so the first item I want to create is the tab manager, which are these tabs right here. All right, so going back to the app. So on the top, I'm going to create a class called tab manager, and I'll pass QTab widget as the parent class. So what I'm doing here is I'm actually creating my own customized tab manager widget. And you can see this as a template to create your own tab widget template. Now for this tab manager class, I want to create a customized signal, and I'll name the signal plus click. So in PyQt framework, we can actually create different signals using the PyQt signal class. Then I'll create my constructor. Now if we look at the code that creates the constructor for the tab manager class. So this line here is going to enable the event filter, which allows us to capture any signal that comes to this tab manager class. And by default, the close button is not enabled. So we actually need to manually enable the close button using the set tabs closable method, and we'll set the value to true. And same thing with the, here, let me go to the right. And same thing with this add tab button. So the button is actually created manually in the tab manager class. And unfortunately, QTab manager doesn't have a default interface to add a tab. Now, if we look at these two lines, so these two lines are how I create the add tab button. So here I'm creating a QTool button to create the plus button right here. And for the display of the text, I'm going to use the plus symbol. And I'll name the button self.add tab button. And to make the signal a little bit more descriptive, instead of click, I want to swap the signal name by using the .connect method. And we'll basically call the plus click signal. And when we click on the close button, we can reference the tab close request signal. And we'll call the self.close tab method to close the active tab. Now here, let me create the close tab method. And this method is assigned to the tab close request signal, so right here. Now if we look at this code block, so basically when this tab close request signal is fired, it's going to pass the tab index where the close button is being clicked. And the tab index is going to get passed to this tab index argument. And to make sure that we have at least one tab open, here I'm inserting if statement. And if the tab count is equals to 1, then I'll basically X out the method. Otherwise, I'm going to close the tab using the remove tab method, and I'll pass the tab index. All right, so here, when I insert the add tab button, the button is actually located in a stationary location. And we need to create a method to dynamically position the button position or location. And to do that, so here we can use the event filter. So when you enable the event filter, in this case, I'm enabling the event filter for the tab bar, which is going to be each individual tab right here. And when you enable the event filter, this event filter method is going to capture any signals that trigger the tab bar, basically. And the signal world contains two items, the widget source and the event type. Now, if we look at this code block right here, so basically I'm saying that if the widget type is a tab bar and the event type is a resize event, they want to retrieve the active tab bar's geometry, such as the height, width, tab location, level location, and so on. But in this case, I'm simply only interested in the height. So I'm going to store the height value into this each variable. Then I can set the add tab button size using the set fixed size method. And these are just the formula that I came up with to set the correct height. And this method here is going to dynamically move the add tab button at the end. Then we need to return the event filter state. So this is going to be everything we need to write to create the tab manager class. Now let's add the tab manager to the application interface. All right, so here I'm going to go back to the app window class. So usually when I'm building PyQt applications, I like to create a separate method to insert the widgets individually. All right, so here I'm going to create a method called initUI. And I'm going to call the method inside the constructor. Now, if we look at the initUI method, so basically I'm creating an instance of the tab manager object, and I'll name the object self.tabManager. Then I add the tab manager widget to the main layout. Now, if I launch the application, so from the main window, so this white area is going to be the tab manager widget. Now, what is missing is the interface. So you can think of this app window and the tab manager as its own template. Now, to create the interface for the personal AI assistants, so here I'm going to create another class called personal assistants. Actually, let me name this to AI assistants. Now, inside the constructor, I'm going to create an instance of the OpenAI Playground object, and I'll pass the API key. So you can think this AI assistant class as another window, except that for this window, we have another set of interface that we embedded to this window. So essentially, we're basically embedding this AI assistant window on the Q tab manager widget. Inside this window, I'm going to create another layout object to organize the widgets. Now, to insert the controls, I'm going to create the initUI method that is specifically just for this AI assistant window. Now, let me look at the application again. Now, to organize the labels and the sliders, I'll be using the QForm layout manager. And I'll name the layout object as inputs, assigned to this self.layout dictionary. And from the main layout, we can actually add another layout using the add layout method. And I'll supply the input layout. And here I need to call the initUI method to insert the widgets. All right, so let's do this. I'm going to create the AI assistance UI from the app window initUI method. So here I'm going to reference the tab manager object, and I add a new tab using the add tab method. The first parameter is going to be asking for the widget that we're going to embed it to the tab. In this case, we want to embed it the AI assistance window. And the second parameter is going to be the tab label. Now for the label, I'm going to name this as conversation followed by the tab ID. So to check the tab ID, I'm going to go back to the constructor. And here I'm going to create an attribute called tab index checker. Now it's set a default value of 1. Alright, so this is annoying. Alright, so here let me do this. I'm going to fix the indentation issue first. Alright, so what I can do here is I can maybe tab out and tab in. And this one too. And that seems to solve the issue. Alright, so going back to the initUI method. Alright, so for the tab label, I'm going to type conversation number, and here I want to insert the tab index. The format self.tab index checker. Alright, so if I go ahead and run the script to launch the app, we now have the tab manager with the AI assistance window, which is blank right now since we haven't inserted anything. And the add tab button is not working because we haven't implemented the method yet to assign to this button. Alright, so going back to the AI Assistance window. Now inside the init UI method, I want to insert the text boxes. The self.prompt object is going to be the input text box, and it's going to be the response text box. And here, I'm inserting the 3 sliders, one for the max tokens, one for the temperature, and one for the presence penalty. All right, so let's look at how we create the slider widget. So when you insert a slider, the slider's orientation is going to be vertical. Now I want to change the orientation to horizontal. So here I need to reference the Qt class, the orientation. Then I'll provide the horizontal constant value. And here's the sliders range. And since for the GPT-3 differential model, the maximum token the API will be able to use is 4,000. So here we're setting the maximum to 4,000. And single step is going to be the distance that the slider is going to travel when you press the left or right arrow key on your keyboard. And page step is going to be the distance when you use your mouse click. And value is going to be the default value when you launch the slider. Now for temperature and presence penalty, and since the slider widget does not support a decimal point, so here I'm using a range between 0 and 200, and I'm going to divide the value by 100 to convert the slider's value into 2 decimal point between 0 and 2. And same thing for presence penalty slider. And here are the 2 buttons, submit and reset. Right, so if we look at how we create the push buttons, the first parameter is going to be the label, followed by the method I want to run when I click on the push button. And here we need to reference the click signal to trigger the button click event. Now for these 2 methods, I haven't created the submit method and the reset fields method yet, which I'll create that in a second. And the last widget I want to create is the status bar. Now to organize these widgets, I'm going to insert a bunch of layout managers. So here let's go to each layout one by one. Right, so because from the queue form layout, you can only insert 2 widgets, one on the left and one on the right. If we look at the max token row, so here the max token label is one widget, followed by the value label, which is another widget. Then you have the slider, which is another widget. And to fit 3 widgets in the same row, I basically create another horizontal box layout object, and I name the layout as slider layout. Inside the slider layout, I'm going to insert the max token label, and which is going to be this label right here. Then I'm going to insert the slider. Now when we construct the row, I'm going to insert the main label first, followed by the slider layout object. And same thing for the temperature slider, as well as for the presence penalty slider. Now to insert the prompt and response text boxes. So here I'm inserting the label, followed by the prompt text box to the input layout object. Same thing for the output or response text box. And to make sure that all the labels are aligned correctly, so I'm setting the text alignment to the right. Then we're going to organize the buttons. So here I'm creating a separate layout manager to organize the push buttons. And I want to organize the buttons horizontally. So here I'm creating a QH box layout object. And I'll add the buttons layout object to the main layout. Then I'm going to insert those 2 buttons to the buttons layout object. And finally, I'm going to insert the status bar at the end of the window, which is right here. So if I click on submit button, and because I don't have any text that provided, so here the status bar is going to display a text, prompt is empty. And this is basically your error message. All right, so let me go back to the top. All right, so if I launch the application, now let's take a look. All right, so let's see, no attribute submit. Okay, now let's go ahead and create these 2 methods, button submit method and the button reset method. Now for the method I'm going to assign to the reset button, it's going to be this reset fields method. So basically, when I click on the reset button, I simply just want to clear the text boxes in the status bar. All right, so here I'm going to assign this method to the reset push button. And it's going to be right here. And for the submit method, I'm going to create a method called submit. Now, if we look at the submit method, so this line here is going to retrieve the text from the prompt text box. They want to insert if statement to check if anything is provided to the prompt text box. If not, they want to use the status bar to show a message. Otherwise, I want to clear the status bar message. As for the self.output clear method, so every time I'm generating a new response, I want to clear the output text box first. Then I want to insert the response from the OpenAI API code. Now, to make the API code, I first of all need to grab the parameter values. So this line here is going to grab the temperature value from the slider. Then I'm going to divide the value by 100 and format the number to 2 decimal places. Then I can run the same prompt request method, and I'll provide the prompt text, maximal tokens, temperature value, and presence penalty value. And once we receive the response back, then we can paste the response to the output text box using the setPlain text method. And here, from the response object, I'm going to reference the outputs key. Then I'll grab the first element. Actually, hold on, let me take a look. I remember I changed the outputs response. So from the outputs key, it's going to return the response directly. Right, so that's actually going to make things a lot easier. So here I can simply reference the outputs key, and it's going to return the response text directly. Then can remove any empty spaces on both ends. And to show the total tokens consumed by the API code, I can reference the status bar, then insert the text to display the total tokens consumed. And to make the text pop, I'm going to change the font color of the status bar to green using the setStyleSheet method. Now, if I run into any error or exception, in that case, I want to change the font color to red. Then I'll display the error message. Right, so let me save the file and launch the application. Now, if we look at the application right now, we now have all the interface created. For max tokens, temperature, presence penalty, the 2 text boxes, and the 2 push buttons. All right, so let me test out the push buttons. Now, everything looks good so far. The next thing I want to do is I want to configure the slider signal to update the label on the left. All right, so if we look at the application again, so right now if I change the sliders bar, the label value is not going to change, and that's because we haven't implemented the signal yet. All right, so let's go to the top. Now right here, I'm going to create a method, and I'll name the method init configure signals. So this method is going to be used to configure your widget signals. All right, so right here, I'm going to use the value change signal from each slider. And I want to pass the slider's value. So this widget here is going to be the max token label, temperature value label, and the presence penalty label. And for these 2 values, because the value is going to be between 0 and 2, so I need to divide the value by 100 and set the format to 2 decimal places. All right, so let me fix the spacing. All right, so I'm going to take this method and I'll call the method when I launch the application. So I'm going to code the init configure signal method in the constructor. Now, if I slide the slider bar, now the label is going to update based on the current slider's position. Right, so the next thing I want to do here is I want to create another method to apply the default settings. Right, so for the method, I'm going to name the method as init set default settings. So basically what I'm doing here is I'm inserting a ticker to the slider. Right, so here I'm inserting the tick label. Then I'm setting the interval between each tick. And by set the set tracking value to true, the slider's value change signal is going to fire whenever we move the slider bar. But if we set the value to false, then the slider's value change signal is only going to fire when we let go the slider bar. And this line here is going to set the default caption for the value label for each slider. And here I'm doing the same thing for other two sliders. All right, so I'm going to code the init set default settings method in the constructor as well. And I'll keep things organized. So we're almost finished with the application. There are just a couple more things to do. Now, what I want to do here is I want to test out the functionality of the application. So here I'm going to ask what is 1 plus 10. And I can use the shortcut Alt-S to run the submit button. And I will return 11 as the response. Now, let me just make sure that all the sliders are working. Now, everything looks good to me, so I'm going to continue. We'll finish with the AI Assistance class. Now we can finish the application by going to the app window class, which is going to be the main window. All right, so let me take a look again. So the add tab button is not working. Now let's create the method to add a new tab. All right, so I'll name the method add tab. And the AI is going to be AI Assistance. All right, so here, when we add a new tab, we want to increase the tab index by 1. Then we can use the tab manager.add tab method. Then we'll insert the widget, and here's the tab caption. And it's going to be identical to this line here. Then I'm going to assign this add tab method to the tab manager.plus click signal. And to configure the signal, I'm going to create the init config signal method under the app window class. All right, so I'm going to call this method right below the init UI method. Now, the last thing we're going to create is the menu bar, which is going to be right here. Now, to create the menu bar, I'm going to create a method called init menu. Now, inside this method, I'm going to insert the Q menu bar directly to the window itself. And to change the background color, when we hover the mouse to each menu item, so here I need to use CSS style sheets. So I'm setting the default background color to this light gray color. Then I'm going to reference the item.select property to change the menu item background color to a little bit darker gray. So this self.menu bar object is going to be the menu itself, but currently it does not contain anything. We need to add each menu item individually to the menu bar object. And we can do that using the Q menu widget. So this is going to be the menu label. Then we need to attach the Q menu widget to the menu bar object. And to create the submenus under the file menu, from the file menu object, we need to use the add action method. And here's going to be the submenu label, followed by the method that I want to execute. Then we can add the file menu object or the file menu item to the self.menu object. Right, so here, let me do this. I'm going to call the init menu method right below the init config signal method. And let me launch the application to see what we have so far. Right, so I haven't created the this save output method yet. Right, so let me make a copy, and I'll take out the method. Right, so let's take a look. So here, noticing that the file menu widget is covering the top area of the Queue tab manager. And to fix the issue, what we can do here is we can go back to the constructor. We can move the main layout towards the bottom just a little bit. Right, so here what I'm doing here is I'm referencing the main layout object. And I'm referencing the first row, and I want to move the first row towards the bottom by 15 points. Right, so going back to the init menu method. Right, so here I'm getting a type error. I need to move this right here. And because I create the main layout right after the self.layout object. Right, so I'll put the line here. Now let me launch the application again. Now this time the file menu and the tab manager are correctly positioned. Now let's finish the application. There's only one more thing to do, which is to create a method to generate the output as a text file. Alright, so let's do this. I'm going to create the last method, and it's going to be save output. Right, so let me launch the application. So basically, this line here is going to reference to the active bar. Right, so for example, here are 4 tabs. By referencing the current widget method, it's going to return the widget that's embedded under the active tab. So this active tab object is going to be referencing the AI assistance window. And from there, we can reference all the widgets based on the object name. So these 2 lines here is going to retrieve the string from the text boxes. They want to insert the timestamp. They want to construct the string that I want to insert to my text file. And to create the text file, I'm going to use the with open statement followed by the file name. Then I'm going to write the content to the text file. Now let me just make sure that I insert the save output method to the add action method. Alright, so this is going to be everything we need to write to create the application. Now let me just save the file and let me close all the applications. Alright, so I'm going to do a test run. So I'm going to open my project folder. Alright, so here I'm going to change the maximum token to 10. And for the prompt, I'm going to ask, what can you do with OpenAI API? And I'll click on the submit button. And because I set the maximum token to 10, so the API won't be able to use more than 10 tokens to generate the response. And if I click on the reset button, it's going to clear everything. Oh, and there's one more thing I forgot to test, which is this save output function. All right, so here let me go back. What can you do with OpenAI? Now, if I click on File, Save Output, it's going to create a text file in my project folder. Now, if I look at the text file, and here's the prompt, and here's the response. Now, let's learn how to package the application. All right, so here I create a template file, which you can download from the link in the description below. And let me open the file. So the file is called pyinstaller underscore template.spec. And let me go to the important properties. All right, so this one's going to be the file name that you want to use to execute the application. In this case, it's going to be the app.py file. And the data as property are going to be the files that I want to include that this application requires. In this case, I want to include the icon file and the OpenAI playground.py file. And I'll keep everything else the same under this analysis section. All right, so let's go to the this exe section. All right, so the name properties is going to be the executable file name. In this case, I want to name the file OpenAI AI Assistance. And if you want to display the console when you launch the application, you can set the console value to 2. But in this case, I simply just want to display the GUI, so I'm going to set the value to false. And icon is going to be the file path that I want to use as the application icon. And for demonstration purpose, I'm going to use this monitor.icon file. And that's going to be everything that I will modify from this template. Now, to package this application as an executable file, now on the terminal, I'm going to type pyinstaller. And here insert the spec template file path. And it's going to be pyinstaller underscore template dash spec. And enter. And looks like I made a mistake. Let me take a look at the template. So let me save the file and try again. And so I forgot to save the last time. All right, so I'm going to run the spec file. And once the process is finished, if you go back to the project folder, you should see 2 folders got created. One is the build folder, and the other one is the distribution folder. So the build folder contains all the files that are required to package the app. Now, if I want to distribute the application, then I want to go into the distribution folder. And here's the executable file that we can distribute to other users to use the application. Now, if I double click on the application to launch the app, and because one of the required file is missing, in this case, if you look at the error message, config.no session error, the OpenAI session is not found. And that's because the password manager file is missing. Now, if I move the file to the project folder, now this time if I run the app again, and I'm able to launch the application successfully this time. All right, so if I type what is 10 plus 10 and submit, and it's going to return 20 as the output. So this concludes this tutorial, and hope you guys enjoyed this video. And feel free to post your question or feedback in the comment section below. And if you find this video useful, please don't forget to give this video a like and subscribe to my channel. And I'll see you guys next time. Bye bye.